2. So, the purpose of this lab is to better understand the Biot-Savart law and to determine the magnetic dipole moment of a magnet. Also to understand the relationship between distance and magnetic fields. The results from this were that the distance dependency number, N, was negative 3.33, and the magnetic dipole was equal to 1.7 amps per meter squared. The main model that is being used is the Biot-Savart's law. This law describes the magnetic field of a dipole magnet from some distance r. The magnetic field is determined by the distance and moment of the magnet, so varying distance experimentally should match up with this equation computationally. Furthermore, by changing the position vector and measuring the magnitude of the magnetic field, the magnetic field can be determined and mapped. Also, this theory can be further simplified by saying that the magnitude of the magnetic field can equal some constant times r raised to a distance dependency number, basically how important the distance is to the magnitude or how much it'll change. And so the experiment was done by firstly orienting the magnetometer at true north by finding out where the magnitude was equal to 0 in the x direction. Then a meter stick was placed east to west, and the magnetometer on the phone was located by finding where bx and by were max and mins at different points relative to a ruler like seen in these images. And then part 1 of the experiment used the relationship expressed earlier with the magnitude of the bar equal to some constant times r raised to the distance dependency number to determine the distance dependency number. So multiple distances were measured and multiple magnetic fields at those distances were measured and then plotted by rearranging this relationship to have a linear look so that n would be the slope of this line. And n was found to be negative 3.33, as can be seen here, where we plotted the data that was taken. Okay. And then part 2 measured the off-axis field at a 45-degree angle, triangle-looking thing, to determine the magnetic field there. So some initial conditions were that the magnetometer was at true north. Some assumptions that were made was that the magnetic north was actually where the magnetometer says it was, that the magnetic field of the Earth was equal to 46.8, like where we were in Georgia, so that we could take it into account for part 2. Please let me live. The system is the magnetometer, the surroundings are the magnet and the Earth field. Some errors were that there were magnetic devices present while taking the measurements. The phone may have been tilted while looking for bx and by max and min values to find where exactly the magnetometer was. And also just so much human error, just so much fiddling with the phone and making sure that it was at the right and appropriate angle. Yes, so this was the math that was done to find the magnetic dipole, and it was found to be 1.7. And then the code, yes, so what does the code do? The code uses arrows to demonstrate the magnetic field from different distances around the magnet. The code also found the value of the magnetic net force from, a 45-degree angle. Yeah, so basically the code is going through and mapping out what the vectors would look like around the magnet and the magnetic field, and then also what it would theoretically look like at that d squared d distance of 0.26 away. And so these were the values found, and the experimental magnetic field and the computation magnetic field are obviously different, and this can be attributed to some of the errors mentioned earlier. Not having the perfect angle for the magnetometer at all times could have changed things. The fact that we had appliances out could have changed things as well. And so here's some what if questions. So, what if you hadn't done everything to find where true north was? Well, then the data would have been off and included the magnetic field of the Earth so that the actual values would not be of the magnet. It would be incorrect. And then what if you had two magnets stuck in together? The magnetic field overall would just be stronger, so the distances would be closer to find those desired values.